Okay, we need to stop now. These are the questions that I've given you. Do we have any issue with today's tool? Anyone? Please turn on your mic and talk to me, yes or no.
Yes, can you talk about it?
Say that again, please.
Can you? I'm not sure if I know how to do it.
Okay. Okay, so the first question that you are asked to do today is log. The base is 4, and the number is 1/2√2, right? Can somebody tell me what they did? For those that did it, please tell me what you did. Then I can chip in one or two things. Guys, we don't have time to waste. If everybody is quiet, the class will be slow and it's not for your own benefit. That's nothing to do with me, trust me.
So I use the second law to rewrite it as like log base 4 bracket 1 minus log base 4 bracket 2 root 2.
You use the second law. So that's log x minus log y. Is that what you mean? Log x over y like this?
Yeah, this one.
Okay, that's one way to look at it. Okay, so you did log 1 to base 4 minus log 2√2 to base 4. Is that what you're saying?
Yeah.
What do you do next?
And then for log base 4 1, you can rewrite it as log base 4 and then 4 to the power of 0.
No, just write that as 0. Because there's a property, logarithm of 1 to any base is equal to 0. So you don't have to simplify it. Just write that as 0 next time, okay? So for the other part, what did you do?
You write it as 4 to the power of 3 over 4.
So this is log, this one, 4 to the power of 3 over 4. How do you get that? I guess I think, isn't that supposed to be 2, 1 plus half? Isn't it?
I just tested it and then I got 3 over 4.
How did you test it? So how did you test that? That's my question.
So I went like 4 to the power of half, 4 to the power of.
This is 2 times that, isn't it?
Mm-hmm.
That is 3 over 2. Or maybe you change this to 4. You change this to 4 raised to power half, then this is 3 over 2. So if you just write here 4 to power 3 over 4 from here to here, if this happens to be something that I'm going to mark, I'm just going to give you 0 because I don't know how you jump from here to writing 4 to power of 3 over 4. So you just write 4 to power of 3 over 4. How? If I write this now on the board, I can bet you more than half of the class, especially those who do not understand this properly, would not understand what you did. So it's of no use to anybody except you. And that's not the goal here. The goal is for everyone to learn from whatever we do. So I've told you to stop skipping steps unnecessarily. If you cannot show your steps, I hope it doesn't affect you. This is not IGCSE anymore, where some of these things are entertained. If you are not able to explain, I doubt if you can achieve, your optimal results in IB. And it's not because you're not smart enough, but just because you're not ready to prove yourself enough. This is not the time to feel, oh, no, it's a waste of time. There's no waste of time when you're proving in math. A simple question like this could take 2 pages in real math. So you don't assume because everybody you are showing this to understands it, so you shorten it to 2 lines. That will not be accepted. So I expect this to be written. Of course, 0 can be ignored. So minus log to base 4. This is 2 to power 3 over 2. I believe everybody understands why these two combine to be this. Can I get a response from the class?
Yes.
Yes.
Okay. So now, if you need to change this to 4, you can, or you could just write everything is equal to x and, use the other stuff. So if you change that to 4, first of all, everything I have here is 2, and this is 3 over 2. But then I do not need this 2, I need 4. If I'm to write it as 4, it has to be 4 to power half, right? That's my 2. Then these powers can multiply because the idea is to get 4 according to what she did. So you have 4, 3 over 4. Then 3 over 4 can be taken to the back now. There's a negative here already. Then 4 to 4. This is 1. Then this is minus 3 over 4. What are the other ways that people have done this, please? But this is not the only way to do it. You can speak, Elsin. I can't look at all the cameras, so just speak next time.
Okay. So first I took the 1 over and I turned it into the power of -1.
Okay, let's take that first. So what Elsin has done is to write this. So you mean everything raised to power -1, where this is 2 root 2?
Yes, that's correct.
Okay, so what do you do next?
And then I took the -1 and put it at the end.
Okay.
Because of the logarithm rule.
Okay, so -1 multiplying log 4 to root 2, yes.
And then I separated log 4 to root 2 into log 4 2 plus log 4 root 2.
Uh-oh, so that will be minus
using
log.
the first rule.
Okay, this, like that?
Yeah.
But it's not entirely correct.
And then because also there's a bracket around everything, so it's negative everything.
So there's a 2 here, and there's a bracket here. Okay.
And then I wrote the first 2 as 4 to the power of half, and then the root 2 as power of 4 to the power of 1 over 4.
Okay, so you have done this as 4 to the power of half, which means square root of 4, and that is 2. And here, you have written as 4 to the power of 1 over 4, like that?
Yeah. And then just,
okay.
And then I put each of the indices to the end of each of the logs, and then I solved it.
Hold on. This is root 2. Many might not know how you did that. So I will say.
Well, I did 2 to the power of half to the power of half.
This is 2 to the power of half. Oh, you mean 4 to the power of half to the power of half?
Yeah, and then you multiply the half of the
I get
indices.
it. So what I'm saying is, I'm trying to explain by showing all the steps, basically. I get what you mean, and that's right. So this is 4 to the power of half. Then this is where our 2 could change, just like we did here. Okay, so this is 4 to the power of half. Then that's your 2 now. Then there's the power of half outside our bracket. All right. Okay, so now we can have here 1/2, 4. This is 1/4. Okay, so I'm trying not to skip too much information. It's better you have more steps shown than less steps shown. Oh, that should be 1/4. Okay, so this is 1, right? Is that what you did, young man?
Yeah, this is what I did.
So that's -3/4. Yes, any other way somebody did it? I'm waiting, please. Is this what everybody did? We're waiting each other's time, you know. So it means whatever I plan today, I won't be teaching today, and you're not wasting my time. So it is better in your own interest for someone to respond and fast.
I use law 6 to do it.
Law 6, explain to us what you did.
I took 1/2√2 equals to 4 to the power of x. So I equated the log 4 bracket 1/2 to the power 1/2√2 to x.
So you said let everything be x. Okay.
And then using law 6, I did 1/2√2 to 4 to the power of x.
Very good. So you change it to index form.
Yes.
Very
And
good.
then I put 2√2 bracket to the power of -1.
So this means 2√2 to the power of -1.
To 2 to the power of 2x.
Right.
And I changed 2√2 into 3/2.
3/2, that is 2 times 1/2.
Yes.
To the power of half, which gives 3/2 to the power of -1, I mean not half. Okay, so at this step, what did you do?
And I multiplied the indices thing, and I made it -3/2
Perfect.
to
So,
and so it's -3/2 to equals to 2x.
perfect. And if you cross multiply, because this is over 1, you get 4x equals -3, which means x is equal to -3/4. And what does x represent? X represents the whole thing. So which means the whole thing is -3/4. That's another way to do it. Good job. Any other approach by anyone else? Any other approach? Is this all we did? Okay. I'd just like to add that this Elson's approach doesn't have to be in this group. So maybe we could write this. So from what Elson did here, log 4, 1/2√2. So I will say log 4, 1/2. I have space here. Log to base 4, 2 to the power half 1. So that's log to base 4 2, 3 over 2, which is log to base 4, to negative 3 over 2. So I can take the negative 3 over 2 to the back. Then minus 3 over 2. This is 4. This 2 will be 4 to power half. Half also comes to the back. And I have log 4, which is 1. So I get minus 3 over 4. Can we see that? Everyone? Okay.
Yes.
All right. So which other question was difficult? With this, I do not expect any issue with the second one, which is 25 root 5. Can I assume that, please?
Yeah, no problem.
Giselle, you're the one asking these questions. Can I assume that?
What? Sorry.
The second, are you listening? Come on.
Yeah, I got the second one.
Okay. All right. So what about the third one? Log A 1 over something something. What about this next one?
Can you explain the fourth one?
Fourth one. Which one is the fourth one again? Let's see. What question is that? Log ln. Is it the one with ln?
Yeah.
All right. The question with ln. Question 4. The natural log of a fraction, e to x. I told you from previous lessons that logarithm to base e of anything can be written as ln of that. So basically, this is written as this. Does that make sense? So that's why you have this in terms of e. So all you have to do is e to power 1 minus x. Am I right? Does that make sense, Giselle? I'm talking to you especially.
Yeah.
So that's 1 minus x ln e. And that is equal to 1 minus x. What is logarithm of e to base e? Giselle, what's this? Giselle, hear me, I have a class in 10 minutes time.
Log.
So what is this one? Okay, how can you write this? If I don't want to use ln, tell me how else to write this. Another way of writing ln is what? Yeah? Justin? Giselle, can you see what I wrote here?
Yeah.
So you don't know how else I can say this ln again? This ln, not the e now, this ln. How else, what does it mean in another way of writing it? That's my question.
Log. Let me see.
Say that again.
Log base e.
So log base, so if this ln is log base e, so can you tell me everything in another form?
I'm not really sure.
I have ln e, right? I just call it ln e. How can I write this? You said log base e, right? Right?
Yeah.
Oh gosh. So what is everything? if I want to rewrite it without ln? That's what I'm asking you.
Log base E.
So log base EE. So does that, why is my pen not working? So does that mean anything to you?
Yeah,
What is that?
it's 1.
It's 1. And what is the final result?
One minus x.
And saying I was talking to Giselle. So if you don't mind next time, stay out of it until I call your name or I address it to the whole class. Thank you very much. Okay, any other question? Because apparently I can't move to what I intend to do today. Thanks to those that waste our time for whatever reason. Which other question, please? I have very few minutes to go. Which other question? Any other question?
I don't have a question.
What about the others?
No questions.
Question.
No question.
Still waiting for others?
No
No.
question.
No question.
Okay. I think because I have not been giving you homework on this, a lot of you tend to come to the class and you forgot what we have done. Well, I will partially blame myself for thinking you can actually just practice on your own without any form of homework. So which is why some of you can't remember how to manipulate this logarithm. So that will have to end now. I have to start giving you work to do. Okay, so for the next 5 minutes before we go, I've asked some people to try number 4 and number 5. Have you been able to do it? Have you been able to do it? Number 4 and number 5? So let's write quickly.
I did 4, but not 5.
Okay, so let's write quickly. About 5 more minutes. 10. Because I have a class in the next 20 minutes. Class is 12:15. So solving equation in logarithm could be of 2 forms. Sorry, just a sec. Okay, so solving equation in logarithm form can be in 2, you can experience this in 2 different ways. If you have logarithm on both sides or if you have logarithm on one side. So if you have logarithm on both sides, if you have maybe log x equals log y, as long as they are in the same base, you can take x is equal to y. It makes sense, isn't it? Logarithm of a number equals to logarithm of another number, then those 2 numbers have to be the same. Do you agree with me, everybody? Aha.
Yes.
So it makes sense to make that assumption. So if you are solving this kind of question, your goal is to make sure you have only a single log on both sides before you can do this, okay? You must have a single log on both sides. Or should I say on each side? Okay, you must have a single log on each side before you can think of that. So please take note. What I'm saying is, if you have log x plus log y equals log z, it is wrong to say x plus y is equal to z. This is not a single log. All right, this is not a single log. Okay, so that is one way to see logarithmic equation if you have log on both sides. So if you have many log on one side, you have to first use this idea of combining log first. Okay, what we did last lesson and maybe the lesson before that, you have to first compress it as a single log before you can apply this. So the second one is, if you have log on one side, which means non-log on the other side, then you apply that log 6. So this one will imply that x equals a to power of p. Remember what OEU just used in his approach to solving that question. Then you apply that. So it looks like a is going to the other side to lift up that p. A is the base, a still remains the base. Okay, this is when you have log on one side, like I said, log on one side. Okay, you can only use this if you have log on one side, please. So a single log, and it's also a single log on just one side. Okay, so you apply log 6. So this is using log 6. Okay, that's using log 6. Does this make sense? Okay, all right. So I will quickly, because I will need to leave in maximum of 3 to 5 minutes. So let's look at this question. Okay, 2 questions before we go. Let's look at the make equation. Okay, maybe I just take from my textbook. Ooh. Sample. One. The case where you have log on one side, let's do that first. Find x if here you have ln x is equal to 3. Now, what is ln again, everybody?
Log e.
Log base e.
Log base e. So feel free to write it as log base e before you proceed. Then you use, this is the second part, second type, okay? So if you have that, it means your x is equal to e to power 3. You can check that in your calculator. Leave that in maybe some significant figures. That's all you can do, okay? You can do that after the class. Just write in your note and use calculator for the last part. So that's one. There is some that I already put in my worksheet. Log to base. Now, in this case, x is the number, not the base. I take one now where x is the base. And the question is log to base x of 81 is equal to 4. This is another question. Okay, again, we apply the law. It means 81 equals x to power 4, which means x to power 4 equals 81. which means x is equal to the fourth root of 81, and that is 9. Is that 9 or 3? That's 3. Okay, that's another way, another type you can see. So the last for today, so I can move on before I get into trouble with the Form 5. So might end up calling the police on me. Finally, if you have log on both sides, maybe I should have numbered it 1, 2, 3. Find x if yes, 1, 2, 3. Sorry. Yeah, my OCD is my problem. So this is 1, this is 2. So let's take this as 3. We have log on both sides. I have log x plus 1 equals log 30. Okay, quickly. First, merge the left because we need one log, right? According to this, you need just one log. If you merge that, you're going to be having log x plus 1 equals log 30. Now, you can see log of a number equals log of another number, then those two numbers must be the same. And this means x plus 1 must be equal to 30, which means x squared plus x minus 30 is equal to 0. That's quadratic, isn't it? Talk to me, please.
Yes.
Yeah, so we try to factorize factors of 30. That would be 5 and 6. To have plus x is going to be plus 6 and minus 5. So then we say either x plus 6 equals 0 or x minus 5 is equal to 0. So x is equal to negative 6 or x is equal to plus 5. I'm going to say that only one of these is correct. Can somebody tell me which one and why?
5, because you cannot have negative in log.
Thank you. Okay, since x cannot be negative, okay, from the first class we said logarithm of b where a is greater than 0. Okay, the log of a number, a negative number, is not defined. Since x must be greater than 0, it means that x must be equal to 5. And that's the end of this. Any questions, please? Class, any question, please?
No, I don't have any.
No.
No.
All
No.
right, so with this, we call it a day. Since that is the case, x is equal to 5. Okay, so we will meet on Friday. I will be posting the stuff online as usual. Then I will see you on Friday. I have to go to my next class now. Have a nice time, and I'll be posting what to be done later. Okay, bye now.
Bye bye. Have fun.